Hello, and thank you for tuning in to this very interesting focus chat with Tudor Gîrba about moldable development. Before you start listening, just a fair warning from my side. Unfortunately, we had a few issues with our Zoom connection, and a couple of times the connection was dropped. Because of this, you'll notice there are some logical jumps into the conversation. However, Tudor has come back to the concepts later on, and we believe that this is still a very useful and interesting conversation. I apologize for these issues. We do our best to make sure that they don't happen, but sometimes technology is what it is. I still hope you will enjoy a lot of this conversation. Thank you so much for listening and enjoy. Hello and welcome to actually the first video that we record in 2022. I'm Alex Bolboaca and coming to you from the Mozaic Works studio, and I'm very excited about today's chat. As we said in the last video last year, we were thinking about mixing things up a bit. So today we are having focus chat with a guest. And my guest is a software environmentalist, co-founder of Think.com, where he works with a team on something called Glamorous Toolkit. He's done a lot of interesting things, but what we are here to discuss is something called moldable development. Novel idea, an idea that evolves tools at the level where we can actually use them to understand code. Yes, that's what I'm getting at. So welcome to Tudor Gîrba.
Nice to meet you.
It was nice to meet you. We were trying to get in touch last year, but couldn't do that very easily. And these past few days, I've done a bit of research on you because the topic is fascinating and it fits a lot of my interests as well. But before we move into the actual topic, I think it would be useful for our audience to understand a bit about you. So my first question is, why did you get into software development and into what you are doing? What drove you there?
So I studied computer science, and then somehow I ended up doing a PhD on the subject, and well, it just followed from there. The focus of my research was around software analysis, software evolution, and also towards programming languages. And then sometime towards 2009, after an extended postdoc, I put forward this idea that maybe the way we are looking at existing systems is not entirely correct. So I was looking at it and said, well, the problem is that we keep saying that developers spend all this amount of time, more than 50% of the time, reading code, but we don't seem to be doing anything about it. The developers are still doing that even today. So is it possible that they're asking the wrong question? And so that's where this whole thing started, and it ended up saying, I ended up formulating this idea that perhaps we should look at, given that we spend so much time trying to figure the system out, to understand what to do next, and perhaps it's more interesting to look at software development as being primarily a decision-making activity rather than a construction activity. And then pretty much over the last 12 years, I followed through on that initial idea. And basically, we're trying to answer the question is, so how does software engineering look like when the way you make decisions is the very first thing that you optimize for, and not how you construct the system. So that's kind of generic and might not be entirely concrete or recognizable for at first shot. Like why is this interesting, or how does it look like? What relevance does it have in for somebody that practices software development? But on the other hand, the way we work, so Think is a company. It's pronounced think and comes from feel and think. So the reason it comes from there is that I believe we think too much in our domain, and we forget that we, as human beings, we are only complete also if we take our feelings into account. And when we talk with developers that work with legacy systems, and we ask them, do you love working with legacy systems? Most people do not associate love with that kind of work. In fact, they would associate more of a negative feeling to it. And I think that's wrong, because legacy is supposed to be associated with something beautiful, something valuable, something that is worth working with. But in our case, it's not. So I think we have to shift the perspective a little bit and then look at why is it that people maybe don't feel so pleasant inside a system. And the way what we do at Think is we are a company, and we fund ourselves by the consulting projects by actually solving concrete problems that people have. And when I say concrete problems, I'm saying maybe there is some sort of a crisis with a legacy system, in which case we need to go and start reasoning about that system. And when we are doing that, we're actually competing with a team that worked on that system for a long period of time. And within a matter of weeks, we put ourselves in a position when we have to say something meaningful about that system that the team doesn't already know. And that's an asymmetric position that we put ourselves in. And the reason we do that is because we want to actually validate this idea that there is the promise of at least an order of magnitude improvement on how we can reason about a system. And that's the reason why we are able to actually do something practical. So our work sounds theoretical, but it has lots of practical implications, and we are actually practicing it on a daily basis. And that's a long answer to your question as to how do we come here. Our mission is to make the inside of software systems explainable. And today, it's kind of take it for granted that software is a black box, especially if you look at how a business looks or regards their system. At most, people can just see or understand it from the outside. Like, I give this input, I get that output, which is not quite unlike how a caveman would understand the world, right? They would just see something new, they would poke at it, and they say, oh, if I poke here, it does this, and if I poke there, don't do that because something wrong happens. So it's a rather primitive understanding of the phenomenon that we have in front of us. And I think we have to open that one up. Like, the systems should not become black boxes, should not remain black boxes. We should be able to open the system and shouldn't be afraid of what we find inside. And not only for an interesting thing is that today the challenge is so large that even technical people have challenges understanding their own systems. So we clearly are not doing something that is sustainable. And by sustainable, I mean we're actually constructing, the body of software grows exponentially year over year. But at the same time, we're unable to recycle old systems. We can't decommission them. We can't reshape them for new purposes, adapt them to new requirements. So from this perspective, we as an industry, we don't behave any differently from the plastic industry. And that's not sustainable. And I call this one the software environmentalism crisis, hence the title of my title. And if I look at the root cause of why is it so hard to recycle the system, is that so before you can take it apart and do something else with it, you first have to understand the parts. And today, the way we understand those parts, the way developers understand those parts, is through manual code reading. And that's the most manual possible way to extract information out of data reading. So, and that's exactly what we do. Now, interesting enough is that as developers, most of our work is about automating somebody else's decision making. Right? Most systems serve exactly that purpose. Right? Some humans will use a system to look at a lot of data and make very fast decisions, right? And specifically, we do that specifically by actually preventing those users to ever see the contents of the raw data. They will never see the raw data, right? They always see representations of this data. So we possess this magic power of actually transforming raw data problems into information opportunities, basically, for that lend themselves as become opportunities for decision making. So we can use exactly the same skills for every single development problem we have, because every single development problem is essentially it contains inside a tiny data science problem. And the way you deal with a data science problem is you first start with a question, and then you build the tool, and never the other way around, right? And but in practice today, right, most people are going to use the same kinds of tools. Like the shape of the tool doesn't change if I go from a system to another. While we think they should change. In fact, they should change if I look at this object versus the other object. This is the granularity at which I think tools should change. And when we do that, we take advantage of our ability to encode or to teach the tool, construct a tool that summarizes what is interesting for us. And we would delegate to the tedious work of reading and just be in control of the kind of we're in control of the hypothesis and of the interpretation. We don't necessarily do the reading. We don't need to do the reading ourselves, because most of the code that we read is actually most of the time we read code, or most of the reading effort is actually a way to search the code that is actually interesting to be read. So if you find a way to not like find the interesting places to read without actually having to read those, then you can gain a large, you can basically do away with a lot of, let's say, wasted effort during this comprehension time. And that's basically what we're doing. And this is what leads us to this Glamorous Toolkit. So as a company, we do fund ourselves by actually solving concrete problems, but at the same time, we are building a theory which is called moldable development. And to show how that one works in practice, we're building also a piece of technology, which is right now called Glamorous Toolkit.
All right. I've seen your talks on this topic, a couple of talks, and I found them very interesting. But and I advise people who are watching this to also watch some of your talks, because you're doing demos on how to use G-Toolkit and how to apply these ideas in practice. But let's start a bit from this idea of moldable development to explain what software environmentalism is. Okay, difficult word. But how would you describe moldable development to a programmer, somebody who actually wants to use this type of approach?
The idea is moldable development is a way of programming through which we construct custom tools for every single development problem. So, and these custom tools are primarily targeted toward to how we read code, not to how we write code. They also affect how we write code. We can talk about that. But the primary target is how we read code. Now, why is this interesting? Well, because so I went around and I talked with lots of developers, and I asked them, do you agree that you spend 50% or more of your time reading code, which is what research that goes back 4 decades now. We see these kinds of figures over and over again in different studies. And the vast majority of the people that I talked to, and I talked to several thousand, they agree with this statement. Yes, I do spend most of my time actually reading through textual artifacts. But then I asked them another question, which was, well, when was the last time you talked about how you read code? So not about the code that you read, but about how you do the reading. And it turns out this is not a subject of conversation. So when something is not a subject of conversation, it's not explicit. If it's not explicit, it has never been optimized. So that's one thing we learned from all this, the agile thinking and lean thinking, is that if you want to optimize something, you need to make it explicit. And that's the thing here is, and every time you want to optimize the performance of a system, for example, you're going to look for the largest, if you can find a chunk of time that is being spent in a single place, and then if that place has never been optimized, then you're super happy because you have an order of magnitude improvement, a promise. This is where the promise of an order of magnitude probably lies. And that's exactly what we see in software development today. We have 50% or more of the time, there's a single logic expense we have. It's being spent on a single activity that nobody talks about. And I think we should talk about it, and we can. And if you do talk about it, say, well, why do developers read code? They read code with a very specific intent most of the time. So if you don't consider the scenario in which you're learning a new language, for example, and you're working with your system that you've been working with for a while, the reason you're reading code is because you want to understand enough to know what to do next, and that's decision making. And so it's much more interesting to look at software engineering as a decision making activity because it's occupies so much time, right? And then you'll say, well, how do I optimize this amount of time? And so from this perspective, if I say that the activity is actually decision making, then reading is just a strategy to gather information out of data. So everything about my system, including code and logs and configurations and data in the database, everything is just data. So, and when I read, I just employ a super manual data mining tool. And we can optimize that one a lot just by, doing what we know how to do best, which is automating tedious work. And so, but then if you look at this problem as being a data science problem, because whenever you need to make a decision about data today, that people would characterize that one as being a data science problem. And if you look at the flow that takes place during data science, or is you always start from a question, and then you figure out, well, what data is interesting for this question, right? So let's say the question is, I want to split my system, but somebody said, well, I can't split the system because let's take the more right. So all of a sudden, there is a dependency between module B and module A. So module B depends on module A, even if there's no direct necessarily call between module B and module A. So if I just look at the code and just look at normal methods, for example, I won't see anything. I won't see these dependencies because it's invisible, right? But if I look at the framework, then all of a sudden I can see. So then, of course, the framework is highly contextual. It probably is homegrown of some sort. So that means that there's no tool from the outside that will ever be able to predict the specific problem you'll have. So which means that if you want a tool, you have to build the tool after you know the context. So you never start from the tool, but you're going to build the tool after you know the problem. Now, of course, the question is, well, how do you make it cheap? I mean, how do you make this one practical? Because it used to be a time. There used to be a time when tools were expensive, and you needed large teams to do, and you needed economies of scale to amortize those costs. But the question that we wanted to that we explored over the last decade was, well, can we have a language that is dedicated towards building these kinds of tools? Can we have an environment in which the tools can be put together at much lower cost than we are used to? And that's basically what the research around Glamorous Toolkit shows, that indeed this is possible. And you can, when we say about much cheaper, we talk about minutes cheap very often. And so Glamorous Toolkit itself, talking about it, it's the first extensive case study of moldable development, in that it comes itself with a couple of thousand custom tools, because that technology too has to be explained. So we needed to explain it to each other. We needed to explain it to ourselves. So we build tools for that thing as well. So when you're opening it up, it already comes with tools that you can use to actually go and understand that piece of technology as well. So coming back, why is it important? It's because it addresses the single largest expense in software development today. And how do we do it? We do it by treating every single problem we have as a data science problem, and the way you deal with this is by building tools, custom tools, after you know the problem. So of course, this one now entails new kinds of skills, very much like how any kind of new feedback loop is. So Moldable development introduces a new feedback loop, very much like how TDD, for example, introduced a new feedback loop, and DevOps introduced a new feedback loop. So when TDD, right, first we had code, and then we had tests became code. When tests became code, the interesting thing is to notice that these feedback loops is that the interesting value is not the one that you see directly. So when TDD became code, yes, indeed, we got tests. But interesting was that we started to have the second order effects were more interesting. So as a business, I had much more trust in my system. But as a technologist, I would, TDD was also a way to guide my design decisions. And that's very interesting, right? And you don't see those things when you're practicing first time TDD, but that's exactly where the value comes from. If I now look at DevOps, yes, I can make deployments faster. That's the thing. That's the first order observation that I can make with DevOps. Once I transition to something or I introduce DevOps, but I don't have it. But the second level observations are the most interesting things. So the kinds, for example, you can see now new kinds of business models that were not imaginable 15 years ago. Right? So before the DevOps became a major subject of conversation, and this feedback loop was practiced at scale, these kinds of business models were just not possible. And so those are effects that you see second, third, fourth levels of observations, and those are the interesting things. So whenever you introduce a new feedback loop, the interesting effects are not the directly measurable ones, but those that percolate afterwards. And with Moldable, so DevOps made infrastructure to become code, right? It was made possible like that. Now we are saying tools have to become code. And so the first thing, right, you will see, okay, yeah, you'll be able to answer questions faster. But the interesting thing is not, oh, can I answer questions faster? The interesting thing is, oh, which questions can I ask? Because now it means I can ask maybe an order of magnitude more questions. If I can ask, if I can, and maybe I increase the confidence of my answers. And when I do that, then all of a sudden I don't have to be uncertain about the reality of my current system. So for example, one of the things we observe when we talk about, let's say, a legacy system, is that people will present us with pictures about their system. So, maybe an architecture diagram, for example. But when we ask people, so, can you bet your salary that the picture is real, right? We're still to find people that are able or willing to do that. And that's interesting, because if you don't know that the picture is real, then it means that if you take that picture as an input, right, that you're basing your decision on a belief, because that picture actually documents, when a picture is manually put together, the picture documents the belief that the author has about the system. It doesn't document the system directly, right? And that's a big difference there, right? So if I take that one away, all of a sudden I'm in a completely different place. The way I make decisions are totally different, and they enable a new way of thinking. And so the same thing. So the same way as how TDD implied new skills and DevOps implied new skills, so does Moldable development imply new skills. So you need to internalize this ability of creating tools very quickly. But maybe a decade ago, maybe it was not so obvious. But now, if I look at the data science space, right, people have kind of internalized at least the skill of taking a question and then creating maybe a notebook or so with visual, with narratives that would support a hypothesis or another, right? So that skill kind of shows that this is possible, except that right now that type of thinking is only addressed to business problems, right? So problems that come from in the customer data domain, right? Domain of the business. But we can use a very similar approach, and then address issues at the technical level. And so that's why we think this is important. So that's what basically moldable development. So essentially is every time we have a question, we're going to stop and we're going to say, well, do I have an appropriate tool? I'm going to say, what kind of data do I need? So if I look at my dependencies of features, right, I might say, well, if I understand how the feature toggles are defined and how they are used based on my framework, I can build a little tool that will show me those kinds of dependencies quickly, right? So that's going to be it's going to be static, some sort of a static analysis. But then it would be also interesting to see, well, actually, which of these feature toggles are used at all, like in the database, because they're going to be set up, set true or false at runtime, maybe different installations, for example, different users, and this here, maybe this question is not answerable through a static analysis. Maybe this information is only answerable by actually observing the system in production. Maybe what people call observability. But observability is just it's a technical, it's a distinction, it's an unnecessary simplification or reduction of the space, because it's the same thinking. It doesn't matter whether I'm reasoning about something statically or I'm reasoning about it dynamically. The source of the data is irrelevant to the goal. The goal is the unifying perspective, and all I need is I just need to make decisions about something about my system, and whether the data comes from some static sources or some dynamic sources or different languages or different forms of representations. Those are just technical details that they are important, but they are still technical. So from the perspective of how I think, I don't want to limit myself to a technical box because I want to just address the business part. I want to address the domain problem as quickly as I can. And so from this perspective, we were thinking, well, can we build a tool that is flexible enough that it actually covers all these apparently different looking spaces? And the answer is yes, we can, because those are actually not different spaces. So the flow of data science and the flow of software engineering are just arbitrarily different today, but they shouldn't be. And the way we reason about an XML or some C# source with the stake in the system should be a stakeholder, and then of course, like then once I have a vague idea of the kind of thing that I would like to see, then I can delegate that one to, or maybe a facilitator can pair with me, build it for me so that I can figure out, is this really what I want? And if it is what I want, then what do I do with it? And then I will be making a decision. So this is kind of the flow that we see. And in practice, for example, even if you have a legacy system, we find that one facilitator to 10 stakeholders is a good ratio to start from when you work with if you want to adopt moldable development. But the interesting things are observable at the process level. So let's say if I do this, I can answer questions faster. But the interesting is not only the questions that are happening at the individual level, but more interesting are questions that happen at the team level. So, for example, how do I ensure that the system goes, like the whole team pushes the system in the same direction, right? Let's say I decided I'm gonna, split this system, or I'm gonna migrate this one to something, the cloud. It's fashionable. So, but to do that is I can't do it in one step. So I first have to untangle these systems here, these three pieces here. They have to be untangled, and I think this might take a year, for example, to do. So how do I ensure? And then of course during this time I'll be implementing the functionality. How do I ensure that during this 1 year I'm not introducing more dependency that will hinder the goal of splitting the system in a year from now? And that's not an individual problem, right? It's a team problem. So now we need to orchestrate the decision making at the level of the team. And the technology is enabling, but is not enough. You also need a process side of things. So for example, this is something maybe we would call as we would name as an architectural problem, right? That is interesting here because if you look at architecture, there are interesting places where today, right? If I look at from an agile from an agile perspective, right? Before a system or before this idea of agility, there was a big gap between business and technology simply because they couldn't talk with one another, and the way it's not like they learned each other's languages. It's just that we created the environment, made it such that because they have to start talking with one another, they were forced to kind of start to understand somewhat whatever they say. And then if you add some domain-driven design on top of it, then all of a sudden you start to enable the conversation at a higher level of semantics, right? But the point here is it's not just say, now you're going to talk. No, you're going to create an environment in which this kind of there's a negotiation happening, right? I have a perspective, you have another perspective, and I'm going to have this negotiation. Now, when do people systematically negotiate architecture? Right? Rarely. Right? It doesn't happen explicitly. Well, why not? And the thing is that here's another question that we ask people and say, do you agree that architecture is at least as important as functionality, at least in the short run, at least in the long run, right? So do you agree that architecture and functionality are somewhat similar in importance in the long run? And people say yes, and it kind of becomes obvious, especially with legacy systems, because a legacy system is valuable today. The problem is it might not be valuable tomorrow because something changes in the environment. And the functionality is perfectly reasonable. But what prevents us from actually meeting tomorrow's needs is the structure of the system, right? So it's how the system works, which means, and that's what generically we can call architecture, for example, or the realm of architecture, whatever architecture means. Let's not go into this at the moment. So if architecture is as important as functionality, it should follow that we should treat it with the same rigor, right? So with functionality, we have a way to negotiate it. We have skills that are targeted to ensuring that whatever we have negotiated actually is the output, right? Testing. We have ways to roll back because we find that something doesn't work the way we want it. All of these things, the skills, the processes, the technology, all of these things, if I apply this one to one business asset, functionality, I should be able to apply to the other business asset, which is architecture. But today it doesn't. And so, but if you look at this little problem of how do I answer a question, right? If I start looking at it differently and I look at the space and I start optimizing for decision making, there are interesting opportunities at higher levels of abstraction. So architecture is one of those. How do I steer architecture for the long run is one of that domain. And again, like both on the technical side, but also on the process side. So the way, for example, we design or we suggest people to think about orchestrating this negotiation that happens at the architecture level is by something we call a daily assessment process. It doesn't have to be daily; it can be hourly or whatever the cadence people choose. But the whole idea is that this is a place. It's to which everybody has to listen, but not everybody can talk. You can only talk if you have data. So it's imagine a process which is optimized not for synchronization, which is what a typical, for example, a stand-up is optimized for synchronizing nodes, right? So what if I'm doing this and I have this problem? Oh, maybe talk with the other one. There's no decision happening there. There's no solution that's being found during this time that is being spent. It's just a synchronization type of thing. But imagine the same kind of effort, same kind of time, but now being highly dedicated to making decisions as a group. Like the outcome is measured by decisions. So in this situation, not everybody talks because most of, talking is not relevant when you make decisions. Only data is relevant. So you can only talk if you have data. So if I have a problem about, oh, look, I saw that somebody introduced a new dependency from this to that, and now this one hinders my long-term goal, then what I will do is I will create a tool that exposes that problem. And once I have that tool, then I will take the results and then I'll say, well, look, there are these 10 places which are doing the wrong thing. And we have to go and fix those. And now with those 10 places, I will go into this conversation, which can be synchronous or asynchronous, doesn't matter. But I will go in this conversation, and this is one of those kinds of inputs for which, for example, the team might decide to stop the pipeline. Because if you're going to treat functionality and architecture equally important, then you're going to, whether you're treating something important or not, whether or not you're stopping the deployment. That's basically the, like people can talk a big game, but the question is, will you deploy with this thing in production or not? So, and what is interesting is that if you're changing, if you take a team of 10 people, and then you start talking about architecture, you're going to have a 3-hour, super highly entertaining conversation, and at the end there will be no decision. If you take the same 10 people and you give them this very, very concrete 10 places, with this very concrete perspective, this should be changed to that, you're going to find a resolution most likely within minutes. In fact, we have a rule of thumb which says if we don't find the resolution as a team in less than 5 minutes, we're going to stop the conversation, because most of the time this means that the data is not clear enough. And so you practice something like this, and then you can, on the one hand, democratize, because anybody can bring up these concerns, which means that anybody can have a stake in the architecture, which means that you can actually do it you can do it at scale too. So you can put some piece of information, some constraint, and put it somewhere else. Some people call it today fitness functions, right? And you can delegate and communicate those. But the important thing is what happens when you have a conflict. The fitness function in itself is not so interesting, or is interesting, but the most interesting place with the situation with the fitness function is when you disagree with it. So what's going to happen when you disagree with the result of the fitness function? Sometimes you're going to disagree with the existence of the fitness function, and how do you take this one in the process into account, right? So that's the key. How are you going to organize that space? And there is a way, and we have a way. We found this a reasonable practice. We've looked at it for now, I don't know, 7-8 years in very concrete settings, and it works. And it's interesting how you can basically include every developer to be part of the or to be an architect, or to participate in the architecture, which they actually do, because that's what architecture is, right? The architecture is the emergent thing that happens that you can observe in the system, and so the only architect that matters is the one that actually puts something in the system, and that's the developer, not the one that talks about what the developer should do. So that means that you always have many architects, which also means that architecture is a negotiation. So hence how you're going to do it. And it's interesting how looking at software engineering and optimizing for decision making solves this problem, but it also can solve business problems. For example, so I was talking about legacy systems, but equally interesting are cases when we work with domain discovery. So like we're talking about domain-driven design. Well, lots of domain-driven designs about putting stuff on post-it notes or on whiteboards, and that's great when you don't have a system. When you don't have a system, you just have a wish, right? And you want to externalize that wish somehow. But once I have a system and I draw something on the whiteboard, that manual thing always represents what my belief about the system is. So people talk about ubiquitous language, but where does this language exist? Because if it only exists in our words and on the whiteboard, I don't know if it's real, right? I know that I can exchange information, I can exchange messages with you, but I have no idea if we actually talk about what the system is. I have to have the system draw itself, simply because of the scale of the system, right? I can't read everything in the system, and that's the problem. So when I have a system, I want the system to draw itself. And whether this is architecture, whether this is domain, sometimes it's about data, sometimes it's about security, performance, all of those things are properties that the system already has. And we should endow the system to draw these kinds of presentations. So very long answer. Yes, not every developer wants to be a data scientist, but there are practical ways to start. And a practical way to start is to just, for example, address the architecture problem. You don't have to go and solve the whole entire software development problem. You can start from the architecture problem, and then just optimize around that one. This one is good enough to provide enough incentives for, right? So for a team to want to start adopting something like this, and then if you as a team you want to adopt it, then you can. The way you do it is, start with a facilitator at 10 developers. If this is not possible, interesting enough, some developers will still want to go and search for something new. And that's the current place where we are at. We're looking for these people that are just totally not satisfied, but might not know exactly why. So they can come and practice and see things concretely and see if this fits or not their specific context. But the thing at the end is that we're building a technology, Glamorous Toolkit, gtoolkit.com. You can go there, you can play with this. It's free and open source. And the reason it's free and open source is because we want people to feel how this whole technique looks like. But at the end of the day, the interesting thing is never the technology, because technology comes and goes. At the end of the day, what we're interested in is just starting a global conversation about how do we deal with systems. And then once we're going to start this conversation, 10 years down the road, we're going to be surprised at the kinds of things that are possible, just because, it's an important subject.
Yeah, and I found it really interesting that you can build these types of tools very easily, and those are the types of tools that I was thinking of when I saw some of your presentations. So first of all, it was about visualizing, but one of the first case study or use cases for me would be definitely in the area of legacy code, where I have a lot of experience and I work with clients. But I think there's also a case to be made, as you said, for the domain-specific visualization, something that we are missing right now. Because as you are saying, we are drawing things on a whiteboard, and then those get turned into text and into files on a computer, and then that knowledge is somewhere hidden inside the code. And I think that's one of the big challenges that I've noticed, and I think you notice this once you have to deal with code bases where you know very little about. So when you first start with a code base, or when you are doing something like me, where you go inside of a code base and start writing tests and refactoring it and figuring out how to change it and how to improve it. But only when you have that experience, you realize how little knowledge actually is in the code. And when it is in the code, it's actually very obfuscated because it's split into various parts. Although, one thing that's very interesting is that everything required for that product to run is in the code. So all the knowledge is there, only you cannot see it. You cannot access it. You cannot. And so I liked very much how you put this, that you are helping developers not to read code. Because reading code, there's something I noticed as well. Reading code is the slowest way of understanding what a product does. What I've used is additional analysis tools and tests. So these are the main tools that I can use to deal with this. But with G-Toolkit, one interesting thing is that you can actually build these visualization tools as you go. As you ask questions, you build a new tool and you figure out what's going on there. Now, I've only used G-Toolkit for about an hour today, so I don't know that much about it. But it seems to me like it's a good thing to use when you need to understand something from your code. Now, would it also be something that's useful when you write new code?
Oh yeah. So the second category of, I was talking about legacy systems. The second category of work we do as a company is actually we work with companies that seek a competitive advantage in software engineering. So you see, when everybody treats, today software engineering is kind of treated as a little bit of a commodity, and it kind of was like this, before the 2000, right? It went to a place where it became a commodity. Everything was externalized, right? And then agility came into play, and all of a sudden, there was a little bit of a spark there, right? Then another wave came with DevOps, right? And then it became a commodity kind of again, right? So things are moving to what kind of technologies you're using and little about the skills that you have to put those things together. But if we're correct, and if this is a new feedback loop, then all of a sudden the ability to exploit this new feedback loop becomes a competitive advantage. So this is the new kind of, another kind of company we work with, and those are typically startups. And one of the application areas is actually figuring out the system before you actually build the system, right? So we here talking about doing the MVP, but what does an MVP mean? Is it just that one that you put on the web and people click on it? But what about a more in-depth problem that you might have, and it's not easily transferable into a large population of very very simplistic actions, right? What if you have those kinds of cases, and we have systems like that, like the interesting systems that are actually running the pipelines of the world today are very complicated. They deal with complicated concepts. But what are those complicated concepts, and how can you find those and have a good idea of what those concepts are before you actually build a large thing? So it turns out that you can use these kinds of this type of discovery and the ability to visualize objects inside your domain, for example. You can use it to improve the conversation with the business side. You can literally pair program with the business. And like this is it's like if you look at, for example, low code, no code type of promises, right? That's not it, because low code, no code, I mean, it could be it if they would also solve the debugging problem, right? Because they most of the time they advertise the build faster, but the build faster is never the bottleneck. That's not the problem that we're having. The real problem if I take a 2-year span, or 3-year or 5-year span, and the building is not the problem. The problem is figuring out what to build and then figuring out how to change. So those are much more interesting questions to answer, and that's almost never a technical problem. So figuring out together how do you enable this conversation with business very, very quickly, that's the most interesting conversation to have. And so we are using these kinds of views, also the same practices, same skills, also for new types of systems. And if you think of it, it's kind of like testing, right? So it's not unlike that one. Like if you think about the utility of it. But at first people say, well, let's do TDD, which is test-driven development. And I start with a test and then I build the code. So you would say, well, it means that it kind of is useful for new code, right? But at the same time, right, you were mentioning, well, I have a legacy system and I'm going to write tests. Well, how do you do TDD when you already have a system, right? Well, it turns out it's actually useful. Same skill, but now a different space. Because those two problems are actually not that different. It's just the idea of how do I map what I understand, and how do I build a little analysis tool. Now, the interesting thing is that the TDD is like a test is an analysis tool. It just so happens that it decomposes the system across functional takes a functional perspective, and this is how it decomposes the system. But there are other interesting dimensions to decompose the system by. You can use exactly the same approach. We can go along with this idea that not everybody has to be again, like this idea, right? That today, when we say, well, everybody is in fact
so
a data scientist, they might not know it. Right? Sounds like
one thing that I was wondering is, because I've seen G-Toolkit and indeed it's,
right.
as far as I understand it, is quite useful for answering questions about existing systems. When you develop a completely new system, do you write the code in a normal IDE and use G-Toolkit to inspect it and to build the tools, or can you also use G-Toolkit to kind of build a system from scratch and start from different views that you want on the system, similar with TDD, but only other types of views, not tests, and then implement it so that it fits what you expect? How does this work?
Definitely, you want every developer to. Right, so there's the practice thing, so the practical thing. So yes, when we create, we often refactor code or change code just because we can't visualize it properly. So very much like how you're gonna refactor your code just because you cannot write a test. But we find that if you follow a TDD flow, you can build an algorithm, for example. But if you want to now visualize the steps, right? So the algorithm, maybe it's going to be imperative. It's going to say, do this and then affect this change and change and have side effects, for example. But if you want to know if you want to now visualize the steps, then all of a sudden you have to have some sort of different structure there. So what's interesting is that we've seen this one many times. These assertions remain the same, but you're going to change the implementation just so that you can visualize, which actually then it took us a while to figure this one out, but it basically shows that thinking about the views that I want about my system exercises the design of my system in an orthogonal way to test it. And that was a surprising finding, and like we didn't expect necessarily this one, but we observed it. Now, how do we do it? So Glamorous Toolkit is implemented in Pyro, which is a Smalltalk system. Which means in Glamorous Toolkit, first of all, is the first language that we support is Pyro, which is a Smalltalk system, as I said. So we are using Glamorous Toolkit to develop Glamorous Toolkit. So when we work there's no external tool, that is the tool. But there's also the second language that we support is the language with which we define support for other languages, of course. So, and the intent here is that Glamorous Toolkit becomes a moldable development environment that you can actually eventually use for creating systems. Now, can you do it for every system, anytime, anywhere today? Obviously not. It's just a piece of technology. But is it possible under the current structure? Yes, it is possible. So if I look at the principle, then yes, I will be programming in the same way, in the same place where I'm going to visualize. I don't want to have two different places. I don't want to think about those. In practice, people will not, like if I look at something like a legacy system, they won't be switching their development environment, after 20 years, probably it's a much harder sell. So from that perspective, it's just Glamorous Toolkit is something that you plug in to augment what they already have. Is that the perfect feedback loop? No. Can it be a significant improvement over what they already have? Yes. So that's basically how we think of it. But at the end, Glamorous Toolkit is intended to be a development environment for all sorts of sources. And the other thing here is, I started from saying that we focus first and foremost on reading, but it turns out that you can actually there are ways to augment how you write in equally interesting manners by adapting the editing part to the context. And when I say to the context, I mean, imagine you have a debugger that looks at a stack from a framework, right? And that the debugger understands the framework. That's the kind of thing. So I don't have to see necessarily all the calls in, I don't know, in JavaScript to reason about React because they're going to be useless, for example. So I would like a debugger that understands React and lets me go and follow my components, for example, at runtime. So there are all sorts of opportunities also at that level.
All right. What I like to do now, since I think we've discussed moldable development in some detail. Of course, what I would advise people is to watch some of your talks to try out the tools, and we can give some more ideas to enthusiasts at the end of this video. But now what I like to do is to ask you a few questions related to other topics or other insights, let's say, that seem similar to or kind of intersect to moldable development, just to get your reaction to it. And one of them that I was thinking about was my friend Llewellyn Falco. He's building an open source tool for testing approval tests, and he experimented with something that's very interesting, which is document-driven development. So fundamentally, he would first write documentation and then go into the test-driven development kind of cycle.
Yeah.
How does this relate or intersect with your views on moldable development?
Yeah, I think anything that Llewellyn is doing is just great. So you know, if anybody's listening to this, go and watch what he's doing, because if you're a developer, he has so many interesting, super practical insights that can be just, you can just take them and put them into practice right away. So yeah, absolutely. There's something that we look at it slightly at a broader view. So for example, in our case, tests are not just tests. So typical tests are void methods. But like if you think about what a test does, it says I'm going to instantiate some sort of state, and then I'm going to assert that the state is like this. So now I have an object, right, that has a beautiful property. And the best thing that the test does is throw it away, right, because it's a void method. And then we say, well, isn't that like a terrible waste? What if I can make the test return an object, right? So if I have an object that I really like, now I assert that I really like it. So I'm very, very sure that I like it. What if I can return it? So if I return that object, and then it means that the test is not the end of the conversation. Because, if I think about a typical TDD flow, right, what do I do? It's red first, right? And then I create the code, and it's green, and the conversation stops. Well, it's like a terrible, it's such a missed opportunity, right? Because, well, why shouldn't it continue? Because that's like, I just have an interesting system. Now I should have a very interesting conversation. But the framework was not necessarily wasn't created like that with this idea in mind. So by just making that test return an object and then combining it with views, now I can start to build interesting documents with the same effort, basically. So that a byproduct of our normal development path is that we can have all sorts of interesting documents presenting various views of the system, various levels of abstraction to different kinds of stakeholders, just out of the box. It's just a normal byproduct. Now, and then we can take it a step further. So it's something we call demo-driven development, which is, the question is, how do you do the planning? So if you're gonna say, if you take a typical agile setup where you have the planning and then you have some sort of a review or a demo, right? Very often the review and the demo at the end is a boring thing. It just says, the story said that if I go here and I click here, then I should get this. So I'm going here and I click, I get here and then I get this. Questions? No. Next. Right? The story says, and it just goes like this forever. Right? The whole point of these review sessions was so that you can have feedback. So if you don't have any questions, if there is no conversation, there's no feedback. So this whole exercise was for nothing. But now, of course, how do you do this? Well, if I take a look at how do people come into a review session, I see, well, they maybe come from, everybody from their own context. They just worked on something, somebody comes from some meeting, and they just get here. So why should they have an interest now? Right? Why don't I entice their interest? So, but then how do you I should tell a story, right? Rather than just enumerating boring facts. But then if I, given that this is a demo, it means that the story must be already in the system. Because if I just talk about something and the system shows something else, then all of a sudden, it doesn't work. Which now means, actually, so I have to have the story before I build the system. So then it means if I go back to the planning, right? If I actually want to do planning, you can also talk about that. But if I just think about what I want to do, right? Then it's the most interesting thing to think about is actually the story. What's the demo going to look like that will entice somebody to ask a question when I'm going to give it? So that's a much more interesting thing than any type of acceptance criteria that you can imagine, because that's the only thing that will entice, that will elicit feedback, which is the only thing that we should care about. So from the demo-driven perspective, you're going to think, we literally think, whenever we think about what we want to build, how will the demo look like? That's the question. And then lots of things just fall into place from there, because the demo doesn't have to be just about what people see, like the user interface, right? You can have a demo about any part of the system, because that's the whole idea of making system explainable. So yes, indeed, this weaves directly with all these potential that Moldable development offers. So you can have all sorts of interesting conversations about anything in the software system. So that's this is how those two actually relate to one another.
All right. Another one, which was actually an idea of mine, for which I also wrote a book, and there's also a video last week on this. I started from the idea that we have every design has a user, except for software design where we think there's no user, but actually the user is everybody who interacts with the insides, with the code structure that is there, and perhaps not only the code structure, but to simplify, I just thought about the code structure. And so one interesting thing happened when we started looking at this and applying usability and user experience techniques to software design is that we realized, as you are saying, that one technique from user experience is that you look at the user flow. So what is the user flow for a developer? Well, you get a task, right? And then for that task, you try to figure out, what do I need to change? And in order to figure out what do I need to change, you need to navigate to different places and perhaps read code or read documentation and so on. But at one point, you need to navigate somewhere, make a change, change some tests, maybe refactor, whatever else you are doing, run the system, make sure it works. And we realized that navigability is not something that we think about when we write code most often, right? We don't think about how to make it easy to get to the specific controller from that specific flow that does that specific validation or something like that. And it was very interesting that by looking at these problems, we came up with various ideas, but I feel like these additional tools that you can add easily would actually approach this problem from a different perspective. Well, what do you think?
No, I think that so. First of all, I love this perspective, saying that like they are users to everything that is the inside of the system. There are users for that one, right? So that's actually a super interesting or super important, I think, realization. So if you think about it, like there's the parallel that I like to make here is, like there's this the Time Machine, a book by H.G. Wells, right? And he's talking about the past, and this guy builds a machine, goes in the past, something happens, and then goes in the future. And in the future, there are two kinds of humans. There are the Morlocks, which live underground and then run the machinery that keeps the world running, right? And then on top of it, on top of the surface, there are the Eloys. And the Eloys, they're just like this, and and then at some point the Morlocks are, it doesn't end well necessarily. So, but the thing is that that's exactly what happens today, right? So, as long as the Eloys, which are customers of our systems, are happy, right? Nobody cares about what happens inside, but inside the system, there are humans there, right? We are there. We live in the system. And I love this perspective that was put forward about 25 years ago, which is called habitability by Richard Gabriel, right? It's this idea that given that we're going to spend so much time, for example, as developers inside the software system, it should follow that the software system must be suitable for human inhabitants, so habitable. Which I think it's beautiful, like as a thing to aim for. And so, but the question is, how do you entice this, right? Because it's not enough to just want to have it; you need to know how to get it. And so, and it's interesting that you mentioned this UX, right? The applying principles of UX. So the idea here is that, because I think this is very important. This is the other very important piece. So on the one hand, there are indeed users there, so that we call them stakeholders. But then, why is UX so important? So with UX, we are showing that we can transform computation into ways that normal humans can actually relate and understand. So that's great. But the other thing to keep in mind is that in software, any boundary is arbitrary. So everywhere I just say this is the interface, it's just an arbitrary boundary to some piece of software, right? And then, for example, for a developer, maybe an API is a boundary, right? But for another one will be some interface that I click on. So, but all of those are literally arbitrary points, right? But what's interesting there, though, is that they actually similar. They share similar properties, which means that if I know how to do something better, so if I find that, oh, look at this boundary, like UX, I can improve it, like say, an order of magnitude. Wow, that's super great, because now I can take exactly the same principles and apply that any other level, arbitrary level that I choose to. Right? So the idea of applying UX design throughout the whole experience is actually, I think it's actually cornerstone. It's super important. And then this is why I think that, so that's at the core of what we are doing, so the perspective that we take. Now, we think that the missing piece here is that you can never experience software directly. So you always experience software through a tool. So even when you edit something, you're never interacting, you're never seeing what you're editing. You're always seeing some representation of the thing that you're editing, right? And by the way, people are doing today, they are reading in an editor, which is talking about UX, right? Editor, right? It was meant to edit, not to read. So we are superimposing another use case on top of a tool that has affordability for something else. And that's one of the reasons why it's so frustrating today to reason about systems, because we're doing it in a tool that has their own properties. So, but now if you take control of this one, if you look at your tool and you realize, well, actually, so there's always a translator between me and whatever I'm looking at. That's my tool. So now it's super important that I can mold this tool to fit my perspective, and that's going to serve the UX that I actually need to reason about whatever I'm interested in. And this should change for every single problem I have, simply because software is highly contextual. So it's highly contextual, which means I cannot predict the specific problems people will have. I can only predict classes of problems. And that's also, by the way, the same reason why people are not downloading unit tests from the web and applying them on their system. People are going to write their tests specifically for their system. Even if they are going to train, doing some sort of training or mutation or property-based testing, it's still going to be targeted to the properties that are interesting for this system. So it's going to be parameterized for the system. And that's a key activity. You can't take it away, because context is so important in software. And the same thing applies for tools, because every clicking tool that you have, every button that you have, and you click on it, bakes the question in the click, right? And that's it, right? That's the problem. So usually you have a question that nobody can predict, and you have to click on some button that bakes some other question that somebody imagined, which might or might not be a good approximation for what you're interested in. Usually it isn't, and this is why you're forced then to manual reading. And so if at that moment if you're not oppressed by that specific tool and you can build your own tool, then you can enable a whole new kind of user experience. So that then leads to a different way of programming.
Yeah. And this actually relates to these very domain-specific views, but there's also the idea of domain-specific languages that has come up, and I think there's somehow of a mix there that you can apply, because until now domain-specific languages are relatively difficult to build. Let's be honest, it's not as easy. But if you can visualize things, I think you can get there easier.
Yeah, but so the thing with domain-specific languages is that typically they have very high expectation they expect it to meet, right? Because you have to have the proper semantics, maybe even a syntax that goes with it, which are reasonably expensive if you want to have them work correctly. But for reading purposes, reading and writing are not the same thing. I do not need to be writing in a specific formalism or in a specific form to be able to enable the drawing of that form, for example. And the other thing here is that every single perspective, there is no single dominant perspective of anything in software. So it doesn't matter how I wrote something. At the end of the day, software is data, and data doesn't have a shape. I give it a shape. And the whole idea of moldable development says that, well, you can give it a shape that doesn't have to necessarily be the editing shape. Right now, right, we just tend to read exactly in the same place where we're writing, using the same form that we use to input, right? But we don't do this for pretty much anything else, right? So nobody looks at like if I take a newspaper, I'm not gonna read it in an editor, right? I'm gonna read it in the way it's meant to, it was meant for reading in a medium that is useful for that purpose, and not optimized for writing. And so those two activities are really, really distinct. There is a correlation, but the other thing to keep in mind with domain-specific languages is that every library introduces semantics, and it's a pity to focus on just those that have easily recognizable syntaxes, because 90% of semantics don't look like that. Like most semantics come from that domain, that ubiquitous language that you build with some basic constructs. So yeah, domain-specific languages do have their purpose, they have their place, but the environment should never be fixed to this. In fact, the environment should first and foremost optimize for how do I enable a framework to show me framework-specific concepts in a way that I can actually go and understand. So that's how I look at it. So there are these two components. On the one hand, focus on the reading and writing are actually not the same kinds of activities. They don't have to coincide. And on the other hand, there are many more languages that we do not recognize today because our environments are too rigid.
That makes sense. And this relates actually to another friend of mine who, unfortunately, I don't remember his name right now. I was trying to remember, but he'll tell me that. What he did was he gave some talks on how to document code, and that perhaps it might be an idea to format code like a newspaper when you are reading it, instead of formatting it like we see with indentation and so on, because fundamentally what you have are sentences, paragraphs, titles, headings. That's what you have. You can apply a different style, and I've seen something like this in G-Toolkit, although not taken that far, but you have a read view on code, right?
Yeah. So yeah, we're going to build lots of views, and sometimes we're going to see the text, sometimes we're going to not see the text. And like there's so many different ways to slice and dice a system. It's just, the interesting thing is never start from the tool, never start from a representation, always start from the question and then pick the representation that is meaningful for this. Right. So for example, if you're following people are following, like the COVID crisis, right? It's interesting how the most interesting or the most eloquent conversations are had around very few charts, right? And that's is exciting, right? Because like there are some interesting charts that will capture a specific topic that is relevant at a certain moment in time, that that people use to communicate a certain hypothesis as to what might come or might not come, and then the whole conversation is about that one, right? And so the those charts actually have evolved over the last 2 years, because different things are interesting at different moments in time. Now, a software system is many times more complicated because it has many times more dimensions than this one.
And I think one last one is, perhaps it's my training as an XP, extreme programming kind of programmer, that I look at dynamic diagrams and dynamics in code that are much more interesting to me than the statics of code. So I'm more interested in how the system works when I play with it, when I feed in data, when I see what I get out or what errors come up. I'm more interested in the kind of dynamic architectural diagrams where I can see how things are moving in the system rather than in the static class diagram or object or whatever. And I think there's a case to be made for tools that show us these dynamic things for complex flows in software in a way that actually makes sense, that can help you understand what happens in the code. So do you have something like this planned? This is just I don't know if you have anything like that.
So we at different moments so for example, for Glamorous Toolkit, we built a graphical stack, which has interesting new properties, but it's not the point. But the point here is that, well, at some point you need to optimize graphical stack. Like if you're working on the web, somebody else will optimize it for you. But in our case, we couldn't, so we had to optimize it ourselves. And the question is, well, how do you look at it? And so when you have a graphical stack, let's say, and you're looking at just you use a normal profiler, which will show you method calls or method executions, then you're missing the point. You're not seeing anything, because an interesting thing in a graphical stack is that you need to see, well, there needs to be 16 seconds at every frame, and I want to understand what happens at every frame. So all of a sudden, if I want to do real profiling of my code, of my system, I would have to have something that actually measures frames, and then tells me logically what happens inside the frame, and then I'm going to optimize. So that's one of those cases in which the same kind of principle applies. It doesn't matter where the data comes from. If in this case it's performance, and then I'm going to say, so I'm going to need to put some beacons in there to tell me, or that will signal, okay, now I'm starting to do this phase, and then I'm going to see the other one. Now the question is, how do I find all those places to put all the right signals? Because if I look at the dynamic of something, if I look at the profiling report, but I miss some signals, if I don't see all the data, then I will make the wrong decisions. So now, how do I ensure that I have all the places covered properly? Now that's an interesting question, because that's usually answerable statically. I'm going to say, oh, actually, I need to, all the places that are doing this should do that. So let's go and find all those places and ensure that all of those places will have the proper logging. So that's now a static constraint that I will add. So, to reason about the dynamic problem, yes, the dynamic problem, and first of all, I needed a custom tool for that. And for this custom tool, I needed a custom model. And to build this custom model, I actually needed to ensure it statically in this case. So those two, they're just different sides of a multi-dimensional coin. And yeah, the same principles apply. And yes, we do those kinds of things as well.
Yeah, and I like this kind of philosophy, and we are getting close to the end, but this type of philosophy, understanding that people and the code are together, and you interact with the code in various ways, and that is, you said you never interact directly, so you fundamentally interact with tools that show you code, but the tools also influence you, and that's this cycle that we are trying to, that I think makes sense to foster, right?
Yeah.
And
Yeah.
I know you were talking in your talks about one this observation that tools model people as much as people model tools.
Right.
And to me, this is very similar with the idea from art that the medium is the message. So fundamentally, what you have,
Yeah. So
what you're
in fact, it's the
interacting with
same.
is, yeah,
Right. It's the same author that taught taught us about both of those things. So it originates with Marshall McLuhan, who was a philosopher in the previous century, right? And he was looking at this idea that you know he was looking at the phenomena of how the TV and radio were massively introduced into the American culture at the time, and the question there was, well, you know, how do those tools influence culture, right? And it wasn't an obvious question. Now it is, right? And we can see how it has many orders of, um, you know, there are multiple levels of consequences out of that little feedback loop. Um, but yes, so everything we do is highly influenced by that perspective. And like as I was saying, right? Where do people read code today, for example? Right? They read it in an editor. So there's a very high degree of correlation. We can't say that this is necessarily a causality, but there's a very high degree of correlation between the behavior. So what does the IDE show you? It just show you a giant text editor, right? So what do people do? They're going to scroll because that's what the editor allows you to do. So there's a very high degree of correlation between the behavior and what the affordability of the tool is, right? So then if you want to change the behavior, because we see, well, there are all these unwanted effects there. If you want to change the behavior, then maybe we should start from the tool. So that's the reason why the two, that's why we have both of these perspectives the same. We tackle them at the same time.
yeah. And one consequence of that, I think, I actually believe that many developers have problems with writing code that is multi-threaded or in parallel, or because the way we see code is linear. So you don't see code as being split into processes or in parallel, or you just see it in a scrolling way, and it's
Exactly.
Okay, this has been extremely interesting, Tudor. Thank you so much. Before we close, I'd like to ask you, for people who are interested in trying out Moldable development, G-Toolkit, what would you advise them to do? How can they start, experiment, try things out?
So before starting any kind of experiment, I advise people to do a simple exercise. Every day, take 15 minutes and look for alternative to how to address, just to look for alternative to readings. Like you can then of course go and take Glamorous Toolkit and play with this. And it's not a straightforward learning curve there because we're talking about new kinds of skills. We're talking about a new feedback loop. This is never easy to get into. But it's there. You can go and practice it. But you can make very concrete improvements on your life just by making that little problem explicit. How do you read code? You don't have to find the answer the first time you're going to ask the question. Just ask the question every day and think of it for 10-15 minutes. You're going to see in 6 months from now, I guarantee you're going to be in a different place simply because you're going to see alternatives around you. Like the alternatives are everywhere around you, but you have to start thinking about it. And after you think about it, you're going to start talking about it. Then, of course, if you want to go deeper and see how far can this go, then you can take a look at Glamorous Toolkit because it's that's what we've been doing for 10 years. So we're kind of like, if you want to see in the future, go look at Glamorous Toolkit. But if you just want to go and improve on where you are today, just do this little exercise and take everybody else with you afterwards.
Excellent. Is there anything else that you'd like to share with our audience before we close?
No, it's just this. Let's start this conversation. So you can do it on your own. You can create a meetup in your local community. Start with discussion together with your colleagues. It can just be enough during your lunch break or any place, in fact. And then if you want to go and have in-depth conversation, if you want to see how this one works at scale or for very complicated problems, we do welcome you in our community. So you can go to gtoolkit.com. That's a piece of technology, and from there you can go and get in contact with us either on Twitter, following @FeedCom, or following me directly at GIRBA, or just joining our Discord community.
All right, thank you so much, Tudor. This has been, as I said, amazing. So there are a few things that I need to do to close. As you've heard, this is a very interesting area of investigation, I think, in software development. I believe it's useful to try these things out. I believe it fits a lot of the existing emerging ideas, and it makes them easier in a way. It makes it easier to look at the code, to interact with it, and so on. And it makes a lot of sense to try it out. But I also realize that there is a large mindset change to go there, so that's why I was saying it's perhaps better to start from a problem, to start by changing your mindset, as Tudor was saying. That's probably what would be interesting. There are a few other videos on this channel that are related. We have an interview with Llewellyn Falco, which was mentioned here, so you can watch what he did, what he discussed with me. And we have to pay our dues to the YouTube algorithm, so please like, share, subscribe, tell other people about this video. Write us a comment if you want to learn more about these types of ideas or technologies. Tell us some ideas, who else to invite to have chats with. We are open to all kinds of suggestions in this area. Until next time, thank you so much for listening, and very happy new year. Let's hope it will be a much better year than the past two. Let's hope that we'll manage to start getting together again in various gatherings and try out things as we used to. But I hope it will be better for everybody. Thank you so much for watching. Let us know what you think, and until next time, remember to think, design, and work smart.